Hello and welcome to Physics Explained by Minecraft, where I take your extensive knowledge of Minecraft and convert it into a basic knowledge of theoretical physics. These types of things get weird fast, and we're going to discuss myths about perpetual motion machines, how teachers have been lying to you about how gravity works, and more. Welcome to Physics Explained by Minecraft. Let's talk about perpetual motion machines. Everyone says that perpetual motion machines are impossible because it's impossible to get more energy out of a system than you put in. While this is true, it is possible to create a perpetual motion machine. Let me explain how. Take a regular, ordinary bicycle wheel and give it a spin. You'll notice that after a few seconds, it stops. Now look at this redstone chain. You'll notice it stops after 15 blocks. Presumably, this is because as energy moves through the wire, energy is released from the wire as heat, and it eventually dies out. It's the same with a wheel. If you spin the wheel, it goes for a little while, and then because of friction, the kinetic energy that is the spinning of the wheel gets converted into heat energy because the friction between the wheel and the axle is slowing the wheel down. As you can see, no energy is being created or lost. It's just being converted into a new form, just like a redstone chain. So it's impossible to create a perpetual motion machine, right? Because if you were to make something that moves forever, you could use its motion to make infinite power. And we know energy cannot be created. Well, not quite. Let me show you how to make a perpetual motion machine in real life. Step 1, obtain a wheel. Step 2, go to space. Step 3, spin the wheel. Congratulations, you have a perpetual motion machine. This wheel will spin forever and ever, but there is a catch. If you try to use the wheel's motion to charge your spaceship, this will slow the wheel down, taking energy out of the system, making the wheel come to a stop. This is a perpetual motion machine as long as no energy is taken out of it, converted into another form. Let's say I've got a redstone chain that loses no energy. I could make it as long as I wanted, but if I powered something in the middle of the chain, the energy would be converted from electricity to kinetic energy, and the rest of the chain would be dimmer because there's less energy. I'm going to tell you exactly how the YouTube algorithm was coded. It's actually really simple, but it's a very difficult idea to wrap your head around. So let me show you a chest. Let's say I want this chest to have this exact combination of blocks in it, in this exact pattern. This is my logo if you couldn't tell. How would a neural network figure out how to do that? I'd start out with, say, 7 chests. The items in the chest would be randomized, and they would be placed in a random order. Then I'd make a robot that looks through all the chests and figures out which one is closest to the desired combination. Then it would throw all the other chests in a volcano and duplicate the good chest. Then it would randomly change the items in the chest, moving them around, taking away some items, and adding some. Then out of these chests, it would figure out the one that was closest to the desired result. This process would repeat until it has the exact result it wants. This is the basic idea behind deep learning. If I want a computer to recognize an image, I wouldn't program it to do that. I would give it a bunch of labeled images, and the computer would write its own code over and over, getting closer and closer to the desired result, until it has very good code that I didn't even write. Our lives are surrounded by these kinds of algorithms, be they the YouTube algorithm, self-driving cars, or deepfake.
Put your hands up, Mr. Beast!
Oh, are you robbing me right now? Gravity doesn't work how you think it works. When most teachers demonstrate gravity, they show a large object bending a sheet and another object rolling around it, which is an alright visualization, but it's pretty misleading. If you were to fall off a very high height for a long time, it would be completely indistinguishable for you from being still in the void of space. And while I can't throw anyone off of any buildings in real life, trust me, I checked, I can do it in Minecraft. So, to illustrate my point, I got 3 Minecraft players and tried to see if they could tell the difference between falling and staying in one place. Hello there, Flouty!
Hello.
Alright, your render distance is set to minimum, so you shouldn't be able to see anything right now.
What is this?
So I'm gonna place a piece of bedrock here, and you can see that you're flying up and down, right? Alright, so I'm gonna break this barrier block beneath you, and the moment I do it, you're gonna do what you just did. You're gonna look straight down and spam spacebar, okay? 3, 2, 1, go. So spam, spacebar. So, hopefully right now you have no way of knowing whether you're plummeting or standing stationary. So right now, I want you to guess.
Can I go into F5?
No, you can't. If you can guess correctly, I will give you admin on my Discord server for 20 minutes. And if you can't, you have to say sub to Pohaku. Quick before you reach the void. Now, everyone I tested this on actually was able to get it right, because in Minecraft you can tell because of view bobbing. This is Slam Move cheating and getting it right. And now, without pressing F3, just tell me if you're following.
I'm not falling.
Are you in
ready?
F1?
I am in F1.
How do you do that? But the point is, in real life, they wouldn't be able to tell. This is called an inertial frame of reference. If you're moving at a constant speed, you have no way of differentiating it from being still, which is why you don't get pushed up against the seat of a car when you're driving unless you're speeding up. Watch me throw the splash potion. As you can see, the liquid in this potion is acting as if it's weightless, and someone in there wouldn't be able to tell the difference between this and sitting in space with nothing around them. That's why, from a physics point of view, falling because of gravity and not moving at all are the exact same thing. When I throw the potion, it goes forward for a second and then curves downward to where the planet is. This is not because a force is pulling it down, but because the space through which the potion is moving has curved, meaning a straight line for the potion is curved for an observer. And what curves space-time? Large bodies of mass, like planets. Let me show you a visualization of how this looks. If we look at these two people on a map, they're walking directly north. Now, let's look at them on a globe. Since they're walking north, they're both headed for the North Pole. But because of this, they come closer and closer together until they're in the same place. But if you look at them on a map, it looks like an invisible force pulled them together, despite the fact that they were moving straight up. This is similar to gravity. Things that are being pulled toward a mass by gravity aren't actually being pulled. The space-time they're moving through is just changing what a straight line is for that object. Thank you so much for watching. I hope you learned something. If a lot of people like this video, I can make a part 2. There's so many interesting physics phenomena to explain. Oh, and this video was really fun to make. Remember to subscribe, and I'll see you next time.